Hello guys, welcome back to my channel. As you know, I'm Likith and today I'll be explaining a research paper from the subject Deep Learning whose subject code is 21CS 743. So let's start with the yeah, topic. Evaluation of deep learning techniques in sentiment analysis from Twitter data. This explores the application of deep learning techniques in sentiment analysis of Twitter data. Deep learning methods, particularly convolutional neural networks and long short-term memory (LSTMs), have shown promise in effectively analyzing text sentiment. So let's start with the introduction to sentiment analysis. So what is sentiment analysis? The process of identifying and extracting subjective information from text data, classifying it as positive, negative, or neutral. So, what is the application of sentiment analysis? Sentiment analysis finds applications in various fields, including marketing, customer service, and political analysis. And third one, social media insights. Analyzing sentiments on platforms like Twitter provides valuable insights into public opinion and trending topics. Then, fourth one being understanding public perception. Sentiment analysis helps businesses and organizations understand how their products, service, or campaigns are being perceived by the public. So, what are the importance of sentiment analysis in social media? So, the importance of sentiment analysis in social media ca- can be classified into these four things. The first one being brand monitoring. Companies can track brand conventions and identify customer sentiment towards their products or services. The next one being market research, where analyzing sentiment towards competitors, products, or industry trends provides valuable market insight. The third one being customer feedback analysis. Sentiment analysis helps businesses understand customer feedback and identify areas for improvement. Then the fourth one being public opinion tracking. Sentiment analysis can be used to track public opinion on political issues, social events, or current affairs. So let's go with the overview of deep learning techniques. So the first one is artificial neural networks, which is the ANN. The artificial neural networks (ANNs) are inspired by the structure of the human brain and are capable of learning complex patterns from the data. The second one being convolutional neural networks (CNNs). The neural network (CNNs) are specialized artificial neural networks designed for processing images and text data, leveraging convolutional layers for feature extraction. Then we have recurrent neural networks (RNNs). Recurrent neural networks (RNNs) excel in processing sequential data such as text, where context and order are crucial, and they can capture long-term dependencies. The fourth one being long short-term memory (LSTMs). The LSTMs are a type of recurrent neural networks that effectively address the vanishing gradient problem, enabling them to learn long-range dependencies in data. The convolutional neural networks (CNNs) for sentiment analysis. The first one being feature extractions. CNNs use convolutional filter to extract features from text data such as word combinations and patterns. Then pooling layers. Pooling layers reduce the dimensionality of the extracted features, summarizing the most important information. Then we have classification. The final layer of a CNN performs classification, assigning sentiment labels such as positive, negative, or neutral based on the extracted features. Then we have long short-term memory, LSTMs, for sentiment analysis. So what is this long short-term memory? LSTMs is it follows first recurrent connections. LSTMs, that is long short-term memory, utilize recurrent connections to maintain context and remember previous information in that sequence. Then we have gates. LSTM cells contain gates that control the flow of information, selectively remembering or forgetting relevant information. Then we have long range dependencies. LSTMs effectively handle long range dependencies in text, capturing context and meaning across longer sequences. Then comparison of CNN and LSTM performance. CNN's So the advantages of CNN include effective at extracting local features and patterns, while the disadvantage being it may struggle with long-range dependencies in text. Whereas the LSTMs have an advantage excel excel in handling sequential data and long-range dependencies. But the disadvantage of LSTMs is that it can be computationally expensive and require more training data. Challenges in applying deep learning to Twitter data. Noise and irrelevant information. Twitter data is often noisy, containing irrelevant information like hashtags, mentions, and URLs. Slang and informal language. Twitter users frequently use slang, emojis, and informal language, which can pose challenges for deep learning models. Then we have short text length. Tweets are often short, providing limited context, making it difficult for models to capture complete meaning. Then we have ambiguity and subjectivity. Twitter data is often ambiguous and subjective, making it challenging to accurately classify the sentiment. So, the pre-processing and the data preparation techniques include data cleaning, removing irrelevant information such as stop words, punctuation, and URLs, tokenization, breaking down text into individual words or tokens for processing. Then we have third one being stemming and lemmatization, reducing words to their root form, standardizing variations of the same word. Then we have feature engineering, creating meaningful features from the pre-processed text data for model training. So, evaluation metrics and experimental results. The confusion matrix, a visualization that summarizes the performance of a classification model by showing the number of correct and incorrect predictions for each sentiment class. Then we have the receiver operating characteristics, ROC curve, a plot that shows the trade-off between true positive rate sensitivity and false positive rate, 1 minus sensitivity, for different classification thresholds. So this ends my presentation. So thanks for watching.